In the first week of this class, we learned that statistics is the science of collecting, summarizing, and interpreting data. Since then, we've been focusing mostly on the process of collecting data, but in this video, we'll begin to talk about the process of summarizing data. In this video, we'll begin to talk about the process of turning a large set of data, like a spreadsheet, into a smaller, more manageable set of numbers that's easier to interpret. One way to summarize a set of data is by calculating values called descriptive statistics. Descriptive statistics are values that are calculated to summarize a set of data. When a person calculates descriptive statistics, a person is using formulas to calculate a set of values that will summarize the important features of the data set that's been gathered. We'll cover several types of descriptive statistics in this class. The descriptive statistics that we'll cover fall into three major categories. The first category is called measures of central tendency, or measures of center. These are descriptive statistics that show the center point around which most of the data is located. People calculate measures of central tendency to get an idea of the point around which most of the data is clustered. Measures of central tendency include the mean, median, and mode. The reason why the mean, median, and mode are called measures of central tendency is because they fall somewhere in the center of a data set. If I recorded the heights of a group of people, the mean, median, and mode wouldn't be down near the lowest height that I recorded, or up near the largest height that I recorded. They would be somewhere in the middle of my data. The second category is called measures of dispersion, or measures of spread. These are descriptive statistics that measure the amount of dispersion, or the amount of spread in a data set. Before we talk about measures of dispersion, we need to understand the overall idea of dispersion. The dispersion of a data set is just how far apart the data values are from each other. When the data values are close together, the data has low dispersion, and when the data values are far apart, the data has high dispersion. Here's an example to illustrate the idea of dispersion. Imagine that I record the exam scores of a certain class, and all of the exam scores turn out to be in the 70s. In that case, my data set has low dispersion, because the data values are close together. Now imagine that I record the exam scores of a certain class, and the exam scores are spread out between 50 and 100. In that case, my data set has high dispersion, because my data values are spread out far apart from each other over a wide range. The four measures of dispersion that we'll talk about in this class are the range, mean absolute deviation, variance, and standard deviation. These four values have their own formulas, but they all measure the same idea or concept, which is dispersion. The third category is called measures of shape. Measures of shape are descriptive statistics that measure the shape of a data set. We'll be talking about the shape of a data set in detail in a later video. The shape that most people are familiar with is a normal distribution or a bell-shaped curve. When a data set has a bell-shaped curve or a normal distribution, then most of the data values are in the middle or medium area, and there's fewer data values down toward the low end or up toward the high end. The two measures of shape that we'll talk about in this class are called skewness and kurtosis. These two measures of shape actually measure the extent to which a data set is non-bell-shaped. When a data set is perfectly bell-shaped, or has a perfect normal distribution, the skewness and kurtosis both come out to 0. And the skewness and kurtosis values both come out further from 0 when a data set is further from being bell-shaped, or further from the normal distribution.